Now we're going to look at how we can do multiplication using base 10 blocks when the problems start to get a little bit more complicated. So if you're multiplying a 2-digit number times a single-digit number, that's not terribly complicated. We can do it like the previous video. But what we're going to do here, when you have a double digit times a double digit number, it does get more complicated. And there's a way that we can do this called an array model, which you've seen before in this section on multiplication. So it's where you're setting up basically like a rectangle, okay? So we're going to do 13 times 21. So what I have set up here is I have 13 on one side. So you've got a 10 and 3 ones. That's 13 over here. And then across the top I have 2 10s and a 1. That represents 21. It makes no difference which one you do horizontally, which one you do vertical. No difference at all. Just set it up however you want to set it up. And we're going to be doing basically like a multiplication chart, and it's going to break this big problem down into a bunch of small problems. So when you have a 10 multiplied by a 10, when these two shapes come together here in this little cell, 10 times 10 is 100. So what we're going to draw in this cell is 100. And then 10 times 10 is going to be another 100. And then 10 times 1 is going to be a 10. So I have it kind of covered up. But to show you kind of this first part, what we're basically doing is we're going to distribute these shapes on the left through all these shapes on the right. So it's like distributing. So 10 times 10 is 100. 10 times 10 is 100. And 10 times 1 is 10. So that's how much we have so far. Now we're going to move down. Now I'm going to take a 1 and I'm going to do 1 times 10, 1 times 10, 1 times 1. And what that's going to give me looks like that. 1 times 10 is 10. 1 times 10 is 10. 1 times 1 is 1. Now do you see how this 10 is vertical, but over here they're horizontal? That's because we're trying this final shape. We want to be able to push it together and make a rectangle. We don't want any parts sticking out on the side. Now if we distribute another 1, we get the same thing. 1 times 10, 1 times 10, 1 times 1. And if we do it one more time, so we have some hundreds, we have some tens, and we have some ones. Let's look at what we have. We have 200, right, the 200s. We have this 10, that's the vertical one. Then we have 1, 2, 3, 4, 5, 6, 6 tens, that's 60. And then we have 1, 2, 3. And if you add that up, you get 273. Or you can think about it in terms of place value. Remember, these are how many little ones you have, how many long ones you have, and how many hundreds you have. And you just literally count the shapes. I have 2 hundreds, I have 7 of the long ones, and I have 3 of the little ones. You can write it that way too. But it's very easy to see it's 273. And this makes a nice little rectangle. If we had actual base 10 blocks and we pushed them all together, we could make a nice little rectangle that would be a 21 by 13 rectangle. But without having to add up all the little tiny ones, this is done like in groupings, so it's 273. So that's how you can do an array model, and I expect y'all to be able to draw one of these, or to look at one that's drawn and understand what's being modeled and how you get all the answers. So let me show you, if you do the expanded algorithm with partial products, how we're going to do the distributive property essentially, and I'm going to show you how the pieces look just like what we drew. So after you've done this a bunch, then you would proceed to this part. This is all like in how you would teach it, right? Get this straightened out here. Okay, so I took the 13 and I wrote it as a 10 plus 3. That's what we have here. And the 21 is a 20 plus a 1, which is what we had across the top right up there, 20 plus 1. So I'm going to take the 10 and I'm going to distribute it first. I'm going to do 10 times 20 and 10 times 1. So 10 times 20 and 10 times 1. And 10 times 20 is 200. And 10 times 1 is 10. And basically what we just created that part of the picture. 200, plus 10. We just did that part. So when we distribute the 10, that's what we get. Now I'm going to distribute the 3. Do this in a different color. 3 times 20, 3 times 1. Well, 3 times 20 is 60. 3 times 1 is 3. 60 and 3. We just created that part of the picture. There's your 60 and there's your 3. So it's kind of like two parts. Here's the top part and then the bottom part. And when you add all of that together, 200, 10 and 60 make 73, 273. But it's much easier to understand these 4 little small bites that we're taking match directly with what we did in the picture. But you notice when you take 2 pieces times 2 pieces, you will get 4 pieces. So if you've done the distributive property correctly, you should have 4 pieces in here. So then that brings us to the standard algorithm, which is really a kind of a crazy algorithm. That's why it's so complicated. Only kids can understand it. It goes like this. You start off here in the bottom right corner. You go 1 times 3 is 3. You write it down. I'm going to extend this a little bit. 1 times 3 is 3. Then you do a diagonal. 1 times 1 is 1. That's what we're all taught to do. 1 times 3, 1 times 1. What did you just create? The 13. You just created a 1 and a 3. I'm going to show you where it is in the picture in a second because it's a little different than this. Then you're taught, okay, now we're going to move to the 2. And you do 2 times 3 and 2 times 1. So each of the numbers on the bottom is getting distributed to the numbers on the top. So 2 times 3, and you were either taught to just mysteriously scoot over, or you were taught to put like a 0 here. And we just did it because the teacher told us to, right? 2 times 3, that's 6, and 2 times 1, that's a 2. And then you were taught to add it up, and you get 273. So let's talk about it. Let's unpack what just happened. So we have a 13 and a 260. Let's see if we can find that on our picture. A 13 and a 260. The 13 in the picture is this right here. It's this part. And this is 260. So this algorithm kind of splits it up into 2 pieces this way. There's your 13. There's your 260. But this is really just the distributive property. It's just we did the pieces in a different order. It's like we switched these 2 pieces right here. We did the 10 and the 3 and the 20 or the 200 and the 60. But that's where this is coming from. And the reason why you have to scoot over, it's not magic. We don't do it just because we were told to. The reason why is because you're not really distributing a 2. You're distributing a 20. 20 times 3 and 20 times 10. That's why we actually scoot over that digit. So let's try another one, and we'll go through the same kind of a process so you can see how the picture matches with the algorithms that we were all taught in school. So if I want to set this one up using an array, I'm going to set up 21 times 32. Again, it doesn't matter which one goes on the top, which one goes on the side. So can you tell which way I did it? The top is 10, 20, 32. Okay, so 32 is the top here. This side is 10, 10, and 1. This is 21. All right. So I don't think my base 10 blocks would actually fit nicely on the picture, so I'm just going to draw these. So we're just going to go kind of one at a time. I'm going to cover up this part for right now. I'm just going to distribute the 10 across here. So 10 times 10 is 100. Kind of try to draw it to scale here. So that's 100. And then 10 times another 10, that's another 100. And then 10 times 10, that's another 100. Oh my gosh, none of these look the same, but you get the idea, okay? And then 10 times 1 would just be 10. 10 times 1 is 10. So each of those are 10 and 10. So we've got 320 so far. And now we're going to do it again. We're going to distribute a 10 again. So we're going to get the same kind of a thing. I'll draw and not talk so it goes quicker. And then we've got a 10 and a 10. Okay, and then for the last part, we're going to distribute this little 1 through there. So 1 times 10 is 10. 1 times 10 is 10. I've got to draw them horizontally so this all makes a rectangle when we're done. 1 times 10 is 10. And then 1 times 1 is 1. 1 times 1 is 1. So let's see what we have here. 1, 2, 3, 4, 5, 6, 600. I've got 40 that are vertical tens. I have 30 going the other direction, and then I have 2 little ones at the end. 672. And this was, I mean, you don't even have to really write this part down, but it's 600s. If you think of it as shapes, we had 600s, we had 7 tens, and we had 2 little ones, if you think of it that way. Now, if we actually do the multiplication, the standard algorithm, let's think about how this would look, okay? 2 times 1 is 2. 2 times 2 is 4. There's 42 right there. That's 42. This side over here. Then we put a 0. Scooch over. 3 times 1 is 3. 3 times 2 is 6. So I'm hoping that after doing the second example, you're starting to see it a little bit more. Of these pieces, it's not random, it's not magic, it actually just directly comes from the picture. But you've got to be able to draw one of these arrays and figure out what is being modeled and what the answer is. All right, and if you can do that, then you can do the distributive property. This is something else we're wanting you guys to be able to do in this class, because this would all lean into how you would teach this. So we're going to do 16 times 34. We're going to do partial products, because similar to how we did it in the previous problem. And it says don't leave out any steps. I want to see all of the work. So the first thing we're going to do is we're going to rewrite 16 as 10 plus 6. And we're multiplying that by 30 plus 4. So notice, you see how the parentheses are butted right up against each other? That's multiplication. But inside here we have addition. So 10 plus 6, 30 plus 4. Okay, so I'm going to start by distributing the 10. I'm going to do 10 times 30. And then I'm going to do 10 times 4. And then I'm going to do this in another color. I'm going to distribute my 6. 6 times 30. And then 6 times 4. So you see how everybody's taking a turn getting distributed to the other guy in parentheses? So the 10 gets distributed to the 30 and the 4, and the 6 gets distributed. And what you end up with is like 4 really small problems. Actually, I kind of prefer this to the standard algorithm. I actually think it's easier. So this would be 300, and then we have 40, and then we have 180, and then we have 24. 4 little small problems. And then for me, it's easier for me if I stack them up vertically, if I'm going to add these on paper or whatever. I prefer to stack them vertically. So that would be a 4. 8 and 2 is 10, plus 4 more is 14, so I have to carry my 1, and then I get a 5. So 544. This is absolutely something you need to know how to do also. Remember, a little 2 pieces times 2 pieces should give you 4 pieces. What happens is a lot of times students forget the middle 2 pieces, and then they only get half the answer. And if you do the actual standard algorithm on this one, 16 times 34, you might want to try that just kind of in any space that you have on this paper and see if you can explain to yourself where the numbers are coming from as you go through it. So these are all ways that you can model multiplication and also teach multiplication, starting with like the hands-on stuff, moving to the standard algorithms.